Welcome, everyone. If you're tuning in for the first time today, let me be the first to welcome you back to an exciting day 2 of the Good Food Conference. As I'm sure you've seen on today's schedule, this is an especially jam-packed and exciting day. We started very early today with our virtual road trip to our global affiliates, starting in Asia, making our way all the way to Brazil later today. Today, we're also hosting our scientific technical track, our startup pitch session, and a slate of exciting investor and startup roundtable discussions. So please do be sure to pop into each of these session tracks to get a full flavor of what's on offer today. As we've mentioned, recordings of sessions you've missed can be found in the replay area of Hopin, which you can navigate to on your lower left. I'm delighted today to kick us off here with a three-way fireside chat that sets the stage for a day of sessions focused on enabling innovation in the alternative protein sector. A couple of weeks ago, I had the opportunity to speak with Tom Kalil and Eric Toone, two of the most noteworthy leaders in fostering innovation in emerging fields like this. Both of them recognize the promise of alternative proteins and had a lot to share with us from their experience. Let's have a listen. Hi, Eric and Tom. It's wonderful to have both of you for this conversation about spurring technological innovation in emerging areas. You both have rich careers doing precisely this sort of thing from a number of different perspectives across other fields. So I'm really excited to learn from this discussion. You both have resumes about a mile long with an extraordinary litany of roles and accomplishments. So I won't exhaustively reprise all of your previous experience in our precious time together, but I will draw on your prior roles as we go along here, especially where it seems particularly relevant to the alternative protein sector's current stage of maturity and technological progression. Tom Kalil is the Chief Innovation Officer at Schmidt Futures, with prior experience in government, non-governmental organizations, industry associations, and academic institutions, all with the overarching goal of catalyzing technological progress to address big societal challenges. Eric Toone is the technical lead for Breakthrough Energy Ventures Investment Committee, following a prolific research career, including co-founding several companies from his research, launching innovation initiatives within academia, and leading ARPA-E, the high-risk, high-reward arm of the Department of Energy. Perhaps I'll start with a bit of a pointed question about the scale of the challenge at hand when it comes to transforming our food system. Tom, you often use this term 21st century moonshots in your current work. What constitutes a moonshot for you, and do you think alternative proteins fit that definition?
I think the answer to that is yes. So there is no one canonical definition of moonshot or grand challenge. But I think the most important attributes of something like this is, number one, there is a clear goal. So President Kennedy said, we're going to put astronauts on the moon and have them safely return by the end of the decade. He didn't say we're going to do more stuff in space. So that's one thing. Second thing is that it would be a big deal if we achieve the goal. So it's more a home run than a single or a double. And third, it's ambitious but achievable. So saying, wouldn't it be cool if we could teleport is certainly ambitious, but since we have no idea about how we would do that, it doesn't qualify as a grand challenge or moonshot. So I think given those criteria and given the importance of alternative protein for helping us with greenhouse gases and increasing biodiversity, and increasing the challenges associated with emerging infectious diseases, I think it certainly qualifies.
Eric, Breakthrough Energy Ventures has made some of the most noteworthy investments in the alternative protein industry to date. And you likewise use bold terms like breakthroughs to describe what's really needed to achieve net zero emissions. Could you talk a bit about the criteria you use when evaluating investment opportunities? And how do you think alternative proteins fit into the equation of getting us to net zero?
Sure. So the first thing, the first criterion that I'd like to make incredibly clear is that we exist to make money. We are not a nonprofit. We're not a so-called double bottom line fund or anything like that. The name of the game here is to make money. And I think at the same time, to show other investors out there that there is a way to invest in this space and make money. We all know what happened in the first decade of this century in sort of clean tech 1.0. So the first thing that I'd make very clear is that we exist to make money. The first criterion that we're going to look at is the impact on the production of greenhouse gases. Breakthrough was created to go after the biggest, hairiest problems out there. And so what we have set sort of as our line in the sand is that we will tackle problems that we believe have entitlement to the mitigation of at least 0.5 gigaton per year of greenhouse gases, or 1% of 2050 global emissions. Now, obviously, you can draw a box around this and you can come up with a million different ways of calculating it. And so where do we get to exactly 0.5 gigaton? Usually what I tell people is, if you need a spreadsheet to show me how you get to 0.5 gigaton, never mind, right? The problem and the idea here is to go after the biggest problems that there are out there. The second criterion that we're going to look at is the technical and the scientific feasibility of what we're of the undertaking. Tom just pointed out that it's critical to go after problems that we think that are stretch goals, but that we think there is a reasonable mechanism to tackle. I think that's one of the ways that Clean Tech 1.0 fell down. Is that we tried to directly map the tech investing strategy onto clean tech. Clean tech, tough tech, and more broadly, requires a very different mentality, requires different timelines, requires a different scale of investment. And so, looking at a range of investments to see what might work out, that's a strategy that doesn't work in this space. So we built a very different organization with a very different group of people in it that are capable of doing technical diligence at a very different level. The third criterion that we'll look at is our money really needed? If there are 10 groups all fighting to get into an investment, we're probably not needed there, right? Our goal here is to be additive. And so we look for spaces where others aren't investing yet. We take advantage of the unique technical capabilities we have to look over the horizon, to look for new topics that we might tackle where others aren't investing yet. And then finally, we look for the opportunity to attract new investors to the space, to bring new money to this space, to increase the size of the pie, if you will, of what's available. So those really are the criteria that we look at: GHG impact, technical feasibility, the need for breakthrough energy ventures, and the opportunity to attract new investors to the space.
Great. Yeah, I love that focus from both of you on pragmatism. Can we actually achieve this goal? I'd love to drill into that a little more and talk about how we move from these bold ideas to actual real world impact on challenges this massive. So as both of you know, alternative proteins right now are just at the tip of the hockey stick curve, so to speak, when it comes to their technological maturity and their commercial traction. We're looking at typically about 1 to 2% of meat sales in the US consisting of plant-based meat, and research toward technologies like cultivated meat has really only begun in earnest in the last 5 years or so. What types of programs, whether led by government, NGOs, academic institutions, do you think are best suited for jumpstarting innovation in an industry at this particular stage of development? Maybe Tom, let's start with you.
Yeah, so there's a range of science and technology policy tools that I've been interested in that I think we're underutilizing. And economists distinguish between push and pull approaches to innovation. So push is I provide a grant or contract for some research and development, and the performer engages in the R&D. And I think that's a critical way to advance innovation. But I also think we can use pull mechanisms. So for example, to address the market failure associated with vaccines, the Gates Foundation and 5 countries went to Pfizer and GSK and said, if you can develop a vaccine for pneumococcal diseases, which is safe and effective, then we pre-commit that we will purchase X million doses at Y dollars per dose. Similarly, NASA went to SpaceX and said, build a rocket that can go up to the International Space Station, deliver and retrieve cargo, and ultimately astronauts. And not only will we buy rides on the rocket once it's available, but we will provide you with milestone payments for intermediate progress towards that goal. So I think one of the things that would be interesting to explore is if one of your goals is to reduce the green premium associated with alternative proteins, whether some of these demand side interventions can be successful in helping to do that more rapidly. Another model is looking at the aggregation of private sector demand. So there are a number of companies who have formed something called the Renewable Energy Buyers Alliance as a way of accelerating the transition of the grid to be carbon neutral. Is there a similar opportunity maybe with some of the larger firms that are also looking at this from a sustainability point of view, where they could help address some of the chicken and egg problems that you have with the new industry of low volume equals high cost equals low volume equals high cost equals low volume.
How about you, Eric?
Yeah, I think that Tom is a great perspective on exactly where the challenge is, and that's the sort of piece in the middle, the so-called valley of death. I think everybody's very comfortable with the idea of the federal government providing a resource to build the base upon which all of these technologies are going to be built through organizations like the National Science Foundation, the Office of Science at the Department of Energy, agencies like that. Governments, for the most part, aren't good at translating those fundamental scientific capabilities into specific technologies and products. At the other end of this, you have investors who are willing to invest to earn a return, but they have a time horizon that is often incompatible with the length of time it's going to turn these fundamental capabilities that have been developed into something that somebody will pay money for. And so the question is, how do you deal with this piece in the middle? And I think that the examples that Tom gave are really excellent examples. We have some agencies like the sort of myriad ARPAs that have appeared over the years to varying degrees of success that try and deal with some part of that middle ground. There are private nonprofit organizations. Tom mentioned the Gates Foundation. There are others who can address some of these things. Groups of industries and of the people who are eventually going to market these products, who are interested in advancing the technologies, but it's sort of pre-competitive, is another really interesting idea, and one that Tom touched on. So I think that it's that piece in the middle that we really need to work on, and to be imaginative and innovative about how we deal with that.
Yeah, I'd love to go back to kind of the early catalytic work to get a field off the ground. Tom, you've led initiatives across a number of different fields to build research tools and fundamental data sets as a means of accelerating a new field. We see a lot of these same needs in alternative proteins right now. There's a lack of open access tools like cell lines and protein functionality databases, which can really slow progress and also lead to a lot of duplicated effort. What do you see as the best mechanisms for creating these types of public research tools?
Yeah, so I think one question is, are there already organizations out there that are motivated to do that work and are capable of doing that work? And if there are, then I think that funding them to create these public goods and making sure that you have IP provisions that, for example, say that the data is supposed to go into the public domain. So that's what was done with the Human Genome Project. There was an obligation to take all of the genetic sequencing associated with the Human Genome Project and put it in the public domain. One idea that we've been exploring is that there is a class of scientific and technical problems that is not a good fit for industry because there's no short-term path to profitability. But it's also not a terribly good fit for academia either, because it requires a higher level of team science and systems integration than you can typically do in an academic environment, or is otherwise not aligned with academic incentives. So it might be that, once you demonstrate the ability to generate this data, and university researchers have gotten their publication out of it, they're not particularly interested in scaling that up. So one model that we're thinking about is a university adjacent time-bound research nonprofit organization. So it has the level of focus of a startup in the sense that there's a CEO and they have a goal that they're trying to achieve. But it has the ability to generate public goods because it's funded by governments or philanthropic organizations. So I think it's always worth exploring what would be sort of the ideal performer for the scientific and technical problem that you're trying to solve.
Yeah, that's a fascinating concept there. Eric, I'd love to dig deeper into your experience translating academic research into real world impact, both as a researcher yourself launching companies and in your role at Duke fostering entrepreneurship. What do you think the alternative protein industry could learn from your experience bridging that gap, that so-called valley of death, as you called it, between basic science and commercial reality?
Well, here I'm going to get on my high horse a little bit and talk about the role of the university in modern society and the role of the university in society going forward. The 20th century was the era of discovery, right? This was very much an era where universities existed to help us understand how things work. That's very much a reductionist view of society, right? I take every little piece of the butterfly wing apart and understand exactly how the light diffracts off it and why. And that was incredibly important. That is also a mode of science and scientific discovery that lends itself to the sort of individual PI, the heroic PI who builds a lab full of graduate students and postdocs and pursues a problem or a set of problems over a period of time and publishes those results in the form of peer-reviewed literature articles that lay a foundation for science. At some level, you're never finished that process. But at another level, that process gets to the point where you can start to say, okay, we understand things at least well enough that we can start thinking about how we're going to put them together and come up with practical solutions to real world problems. And what I did while I was at Duke was to try and make the case that is something that the university absolutely positively has to do to be relevant for the 21st century, to start to address real world problems. You know, we have to remember that at the end of the day, many of these activities, most of these activities are paid for by real people, right? And those real people have real world problems that they have to address, how they're going to deal with aging parents, how they're going to put their children through school. And I think that universities have a responsibility to provide practical solutions to those problems. I think that we've arrived at a time when that reductionist approach to science has left us a base of knowledge that's sufficient to start to develop integrative solutions to these real world problems. That is a very different mindset than the mindset that has dominated the university for the past 75 years. It involves bringing multiple people together with multiple experiences and expertise. You know, from fundamental science to manufacturing to marketing to everything. That's not something that the university is good for. And I think developing innovative solutions to allow the formation of those groups of people, very much again, you know, Tom hit the nail, I think, exactly on the head, like the kinds of solution that Tom was discussing. But I think that this is almost an existential issue for the university in the 21st century.
If I could jump in on this, I think there's a number of things that universities can do. Obviously, they can recruit people like Eric who understand both the world of academic research, but are also interested in this question of real world impact and research commercialization. I think other things that universities can do is to encourage students to major in a discipline but minor in a problem. And what I mean by that is that by the time they leave, they've had a critical mass of both curricular and experiential learning around a particular problem. So they might decide, I'm going to major in molecular and cell biology or biochemistry, but I'm going to minor in the problem of alternative protein because that's ultimately what I want to go off and do. And I'm going to have a set of experiential learning opportunities and internships and entrepreneurial activities and courses in other disciplines that allow me to understand this problem from a systems perspective. And I think one thing where I think universities are still falling down on the job, particularly at the graduate student and postdoc level, is assuming that all of the graduates are going to go off and become tenure track professors at R1 universities. They're not. If you look at the numbers, only a small fraction are going to be doing that. And I think we're doing those students a disservice if we're not preparing them for a greater range of career opportunities. And one of those is helping to move this incredible, this incredible advances that we've made in terms of science and technology and using it to help address some of our most pressing challenges.
Here, here. I think that those are great ideas, and you certainly see that many of the graduate students and postdoctorals in people's labs are very, very interested in doing exactly that, in taking these ideas, these solutions outside of the university. They're also at a point in their lives where they're able to do it. You know, they don't have 2.5 kids and a mortgage that they have to take care of. They're at a time in their life when they can take some risk. And if things don't work out, well, I'll sleep on a buddy's couch for a few months while I figure out what I'm going to do next. There's a tremendous opportunity to do these things. The students, the undergraduates, the graduate students are absolutely hungry for it. You find the alumni are extremely interested in this. David Rubenstein was the chair of the board of trustees at Duke and was the supporter of INE while I was back. These people understand the university is a big, big, big challenging ship to steer.
Now, quickly in our last few minutes here together, I'd like to ask you both, what do you think would be the single most game-changing development to accelerate the alternative protein field over, say, the next 5 years, whether that's a government or philanthropic commitment of some sort, formation of an industry or investment consortium, launching a new initiative or agency, or something else altogether? Let's go to you first, Eric.
I think that you're going to have to bring the people who are actually going to deliver the product to consumers into this. I think that we have to get so you have to avoid the sort of hammer in search of a nail problem, and that's always a challenge that you have when you get to translating academic research. But I think that integrating more closely the people who are going to deliver the product to customers, people who understand deeply both what consumers are looking for and how these materials are going to be marketed, how they're going to make it to market, and making sure that those boundary conditions are firmly entrenched in the minds of the researchers who are developing these products is really going to be critical. So again, it's that integrative approach that looks at the total solution from end to end, and I think that's a huge challenge.
And how about you, Tom?
I would be a fan of an initiative that was informed by a techno-economic analysis of where the biggest opportunities are to reduce and hopefully eliminate the green premium. And then once you have a sense for what those are, to look at a myriad of solutions, both on funding R&D, but also in using some of these market shaping approaches that I've been talking about, like advanced market commitments, milestone payments, incentive prizes, aggregation of private sector demand, and volume guarantees as a way of, as rapidly as possible, driving things down the learning curve and getting economies of scale as a way of lowering prices, so that this is a no-brainer from the point of view of consumers and a no-brainer from the point of view of firms and investors.
Fantastic. Well, thanks so much to both of you for sharing your insights. I have learned a lot from this conversation, and I appreciate your time, and I'm looking forward to the rest of today's conference. Thank you.
Thank you.
Thanks very much.
I hope you all enjoyed that conversation as much as I did, and I think we can all draw on those insights throughout the day today. Before we close for this morning's plenary, I'm pleased to share first a special announcement and then one additional voice, that of Representative Haley Stevens from Michigan. First, for our special announcement released to the media actually just a few moments ago, I'm incredibly proud to share that GFI has just awarded nearly $5 million in research grants to over 20 leading scientists from around the world. Their research will address the scientific barriers to producing thick, structured, three-dimensional meat alternatives. This catalytic open access research is designed to help alternative meats break into the vast whole cut meat category, the so-called holy grail of alternative proteins. While GFI is nearing $13 million in total grant funding awarded since 2019 when we started our grants program, and is one of the largest funders of open access cultivated meat research in the world. Of course, a significantly greater scale of investment from governments and the private sector is still needed if we're going to unlock the innovations that our future food system requires. So I hope that conversation we just heard provided some really concrete examples for how we might go about unlocking that greater scale of funding. And that is exactly why I'm very excited to close this morning's plenary with remarks from Representative Haley Stevens, one of the strongest supporters of investing in research and technology in Congress today. Let's listen in.
Hi everyone, Congresswoman Haley Stevens here, proudly representing Michigan's 11th District. I want to start by thanking Dr. Liz Specht and Mr. Bruce Friedrich for their incredible work in advancing the field of alternative proteins and for bringing us all here together today on behalf of the Good Food Institute. As a Congresswoman, I am laser focused on our advanced manufacturing and supply chain economy. Particularly around workforce development, our research and development opportunities, and all the ways that advanced manufacturing impacts our lives. I sit on the Science, Space, and Technology Committee. I serve as a chairwoman for research and technology, overseeing a lot of the components of the National Science Foundation and the National Institute of Standards and Technology. But one of the things that I want us to focus more on are the ways in which we access our food, manufacture our food, even consume our food, and dispose of waste. And in particular, with alternative proteins, one of the things that we know is that this is a fantastic scientific research area. And as someone who was working hard in Congress to make sure that we have the budget for scientific research and the diversity at the table with our scientific research, I know that alternative proteins are going to be so critical to the research endeavors that are funded and inspired by the federal government. For instance, for all the aspiring scientists out there, we know that if you were to roll up your sleeves and start researching different components of alternative proteins, or even espousing some of their benefits, if that's antibiotic resistance, fighting back against pandemics, sustainably feeding billions and billions and billions of people into the year 2050, we've got a path here with alternative proteins, and we certainly have a very compelling area of research. I was also very pleased to see, and not surprised to see, that the National Science Foundation made the first ever grant for the study of alternative proteins to UC Davis to the tune of, I believe, $3.5 million. That's a great first start, but where we want to go in Congress is to make sure that the National Science Foundation, alongside that other big federal agency, the USDA, are working together to unlock the potential to sustainably feed people and also tackle some of our bigger challenges as a society as it pertains to climate change and other activities. You can hear the bell going off because I'm sitting in my congressional office and they're getting ready to call us in for votes. That means we're busy, but we're not too busy for you and our friends at the Good Food Institute. And I want to thank you all again for doing what you do, being dedicated to a field of scientific research that I care so much about. And please know that Congresswoman Haley Stevens from Michigan cares a whole heck of a lot about what you do and wants to collaborate, learn, and inspire together. Thank you.
Now that is an inspiring way to send us off to our next session. As a reminder, recordings of these sessions will be available in Hopin shortly after each session ends, and most of the content from this conference will also be available on our YouTube channel later this month. I also want to encourage you all to make use of the networking opportunities and the expo hall throughout today to connect with the fellow innovators at today's conference. It's not every day that you get to be in the same virtual room as hundreds of other folks who are as enthusiastic about this field as you. So thanks for joining me here this morning, and I wish you an energizing rest of the day.